Hey guys, so today we're going to be doing a tutorial with NextEngine's Ultra HD 3D scanner. We're going to be scanning my roommate's bicycle seat and importing this as a point cloud into SolidWorks. We're going to cover the apparatus and mounting, just different techniques that you can use and things that we found helpful. We're going to cover the software settings and just covering some trouble areas that we ran into and ways to avoid them. So here's the seat that we're scanning. We thought this was a good option just because of the different holes and geometry that you've got going on here with the rails. So it'll add some complexity to your model, which could give you difficulties depending on your settings. And we'll show you some techniques how to handle that. Also, it's an important thing to note, when you've got your 3D scanner, everything not perpendicular to the scanner is going to have a really hard time being picked up. So that's talking about the top of your seat, the bottom. So this is NextGen's standard apparatus used for mid to small size objects. We're just going to mount our seat here in the center. There's a few different configuration options, but you can't really go wrong with putting it in the center. The way this works is the scanner takes a scan and then the apparatus will rotate, and at the end it will stitch all of those different scans together into a point cloud. Another thing you're going to want to pay attention to, the software will talk to you about this, but you just want the distance between the center of your object and from the scanner to be slightly more than 25 inches. So now we're going to use NextEngine's Scan Studio software. Start it up here. Okay, so the first thing we're going to do is in the top left hand corner, hit Start. You can hear the scanner turning on. First thing you're going to see is a video feed of your scanned object. So here I can move it around. And you're just going to want to make sure that it's centered. Also here you've got your model name up the top. So I'm going to change this to bicycle seat. Okay, so in our settings here we've got your different kind of scans. So this is a 360-degree angle shot, your bracket shot, which will cover 180 degrees, and a single shot. We're going to go with 360 degrees. The next setting is divisions. So this is the number of images taken per 360 degrees, with a minimum of 4 and a maximum of 16. Below that is points per square inch. So it also has a minimum of 90 points per square inch, all the way up to the Ultra HD of 7,000 points per square inch. Okay, so in the target, this covers your color of your object with dark, neutral, and light. Originally we went with dark because of the black seat. With the reflectivity of the seat, we found that neutral actually ended up working better for us. So in our range, we've got 3 different options. Macro has a 10-inch focal length. That's for slightly smaller options, so this didn't work for us with the seat. Wide angle has a focal length of just over 25 inches, as I mentioned before. And the extended option is only available with ProScan, so we're not going to be looking at that one right now. Here, this also has time and memory indicators showing us the length of our scan and the amount of memory used per scan. This is quite high right now, very high, because this is still in Ultra HD. So as I change these settings, this is going to change around, or change our time and memory usage. We found that divisions and points per square inch were the most important settings for our scans. The first time we went to use the software, we set our divisions quite low just to make a quick scan and try everything out. And the way the scanner works is it takes a different scan and collects points. And as it goes around, if you don't have enough points that are intersecting, it just can't recognize that it's the same object. And so it looked good right until it finished, and then the object ended up flying apart. So you're going to want probably a minimum, I don't know, maybe of 8. With our bicycle seat, because of the rails in the back and the holes and the different geometry going on, we found, I don't know, 12 is a good minimum for us. We're going to go with that for this one just to make a faster scan. Here in points per square inch, our first intuition told us that the more the better, but importing this kind of smooth object into SOLIDWORKS, really this didn't help us at all. So it will probably help a lot with knitting the image together. We're going to stick to this quick settings. As you move up in these 3 divisions, it drastically affects the amount of time your scan takes and also the amount of memory. And that's a big thing to keep in mind. If you've got 100% memory usage, you could run into problems later. So we're going to stick to quick. We'll go with 200 points per square inch. We're probably going to have to reduce this, just because you don't really want a large file going to SOLIDWORKS. If all of your settings looks good, we're just going to hit start.
So here we have the resultant scan. This is the viewing area in here. You can spin it around and zoom in and out. Down here is where your different scans will be. So if we had taken separate scans, they would be along here at the bottom. There's several different viewing options. Right now we are looking at the view with the picture projected onto the scan. There's also just the shaded view, as well as the mesh view and the point cloud view. As you can see, the stand is still in here. So first off, we are going to go to the trim function so that we can remove the stand. It saved a backup model for us. So I'm going to use the rectangular selector to select the areas that I want to remove. Looks pretty good. Let's trim that. As you can see, the stand is gone. So now we're going to go back to the main menu, and now next up we're going to fuse the scan. So the fuse takes the scans and it fuses them into one mesh. So we're going to click on that. There are settings here. You can change some of the characteristics of your fuse, but we're just going to stick with the default settings for now and select fuse. After the fuse function ran for a couple minutes, the final result was this, which looks pretty good. In comparison to before the fuse, as you can see, the bottoms and the sides and the tip are missing quite a bit of data points. The fuse did a good job of interpolating and coming up with a good point cloud to work with. The biggest noticeable problem being that the rails on the bottom were not connected and kind of deformed. This could be improved by increasing the amount of divisions in the scan. It should also be noted that NextEngine recommends using white objects or powdered objects, and this bike seat is a black glossy object, which reduced the quality of the scan right there. I'm happy with the quality of this scan, but if it were to be worse, we're going to show you how you would solve that if these gaps cause such deformation that your object scan is not satisfactory. So this is a scan that we took about a month ago, in which we took an additional scan and aligned them over top of each other in order to fix this gap up here. As you can see in this scan, the rails are actually quite nice, and that was due to having a higher amount of divisions. There were 16, as well as having a higher point density collection. So in order to do this alignment, you need to take another scan. So we took a scan from this angle to get some data points on the front. So this was the result of that scan. And we're going to use this point in common to align them together and make one point cloud. So here we go to the Align tool. As you can see, these points have been placed already by me previously, so the colors correspond to each other. It's preferable to actually have at least three marks on your object. In this case, we only had one, but we just approximated these blue and yellow points, approximate distance away, that looked correct, and it worked out quite well. We selected a line, and then we fused it together, and the result was this. The tip is fixed, and another step that we took in order, as you can see, the point cloud density has reduced quite a bit from here. You do that by going into the Polish tool, and we use Simplify. So you can increase or decrease this tolerance, which when you increase the tolerance, it removes points that are less than that tolerance away from other points. So it makes the point cloud less dense. So we simplified that. The result was we actually went from a file that was 200 megabytes all the way down approximately to 2 megabytes. So it was almost 100 times reduction, which makes using it in SolidWorks much simpler. There's also a CAD option. So if you have the CAD option paid for, then you can use these surface tools, spline tools, and you can orient it. You can actually use it even if you don't have the option, but you cannot save it out. So in order to use your point cloud in SolidWorks, you need to save it. So we found that the best file type to save it as was the XYZ files and the VRML files. So after you save that out, you can open that up in SolidWorks. Hey guys, thanks for watching our video. Hope you find it helpful with your first few scans.